In this last lesson for homework packet 6.1, we're going to take a look at one final type of transformation on functions, and that would be reflections. There's two primary reflections that we're going to worry about, and those two reflections are reflections about the x-axis and reflections about the y-axis. Now, as we approach the next four problems, as we look at examples of these, keep in mind one thing. You may want to write this down. If you want to reflect about the x-axis, you make the entire function negative. If you want to reflect about the y-axis, you only make the x negative. Okay, so think opposite here. If you want to reflect about the x-axis, you make the entire y equals equation 0. So if you want to reflect about the x, make y 0. If you want to reflect about the y-axis, you only make the x negative. So you put the negative the opposite place of what you're reflecting on. If you want to reflect about the x, the whole function y equals becomes negative. If you want to reflect about the y, only the x's become negative. So we've got our first example here again of our y equals 2/3 x minus 4 equation. Let me graph that really quick. And I'm going to make sure that I label my x and y-intercept. So my y-intercept right here is at 0, -4. My x-intercept is at 6, 0. And it's asking me to reflect this about the x-axis. So we want to reflect it about the x-axis. In other words, the x-axis is going to act as our mirror. Well, if we recall back to that previous slide, in order to reflect about the x-axis, you make the entire y equal equation negative. So you make the entire f of x negative, which would end up being negative 2/3 x minus 4. I'm going to distribute that negative to everything, and I get negative f of x is equal to, here it is, negative 2/3 x, but then distributed there, plus 4. So here is my new equation reflected across the x-axis. Did it actually accomplish that? Where is my new y-intercept? My new y-intercept is at positive 4 instead of negative 4. That sure looks like a reflection about the x-axis. I was 4 below, now I'm 4 above. Now my slope is negative 2/3, so that's down 2 and over 3. Down 2 over 3. Look what we have here. I've got a new equation. Notice that since I was reflecting about the x-axis, the x-intercept didn't change, but my y-intercept did change. It went from 4 below, like I said, to 4 above. So my new y-intercept is at 0, positive 4. And you can see that across that x-axis, it does look like everything got reflected. Everything that was above is now below, or everything that was below is now above, and it's equidistant from that axis of rotation, the x-axis. Let's see what this looks like in the context of an exponential equation. Graphing this really quick, it's one of the ones we've been working with for a while now. So negative 4 is my horizontal asymptote, and I believe my y-intercept was at a negative 1 and my x-intercept was at 0.98. So let me label these as 0, -1 and 0.98, 0. And it was growth. So there it is. Now, what we wanted to do is we wanted to reflect this about the y-axis this time. Instead of the x, we're reflecting it about the y-axis. Now, interestingly enough, as you recall from that one of the first slides, if you want to take and reflect about the y-axis, you only make the x value negative. So that's g of negative x. Not negative g of x, but g of negative x. So we're only making the x negative. Everything else stays the same. So it's 3 times 1.4 to the negative x minus 4. And this is what we're going to leave it as. And there is some potential manipulation you can do here, but we're going to call it good. We're going to be okay with it as is. Excuse me. So what does this look like reflected about the y-axis? Well, again, in this case, the y-axis is going to serve as our mirror. Everything on the right-hand side is going to flip to the left. Everything on the left is going to flip to the right. So what does this end up looking like? My y-intercept stays the same because it's right on the axis of rotation. But my x-intercept right here, which is at 0.98, now comes over to negative 0.98. So negative 0.98, comma 0. And instead of growth, it's going to be perfectly reflected into decay. So it's been reflected across that y-axis. What was on the right is now on the left. What was on the left is now on the right. If I were to rotate back over, they'd match up perfectly with each other. And notice again that all the points not on the y-axis reflect, but everything on the y-axis stays where it is. So our third of 4 examples is back to our quadratic right here. We remember that our vertex is at 3, 5. And if you recall, our x-intercepts were at 5.24 and 0.76. Then I believe our y-intercept was at negative 4. So that puts a negative 4 over here as well. So there's our quick parabola of this original equation over here, f of x equals negative x minus 3 squared plus 5. It's asking me to reflect this about the x-axis. About that x-axis. So here's what we do. Going back to this original equation, what does it look like reflected about the x? We recall that if you reflect about the x, that's when you make the entire equation equal, or the entire equation negative. So that becomes negative f of x, which is negative x minus 3 squared plus 5. This negative gets distributed into both terms, and it becomes negative is a positive x minus 3 squared, and then a minus 5, because the negative 1 times 5 is negative 5. So notice with this new equation reflected about the x-axis, notice where the new x, or the new vertex is. My vertex was here at 3, 5, but notice where it is now. It's at 3, negative 5. 3, negative 5 is right here. So the vertex has reflected down across the x-axis, equidistant just on the other side. My x-intercepts are going to stay right where they're at. But what about my y-intercept? To find my y-intercept, we plug 0 in for x. 0 minus 3 is negative 3. Negative 3 squared is 9. 9 minus 5 is a positive 4. So notice my y-intercept went from negative 4 to positive 4, reflecting across the x-axis. And because of that, we now have a reflected parabola that looks like this. Everything that was above the x is now equidistant below. Everything below is now equidistant above. So there it is, reflected across the x-axis. The last example we have is our radical equation. Graphing the original, I believe that our starting point is at negative 2, 4. Negative 2, 4. And if I recall from the other lessons, the y-intercept is at 2.59. So let me label this 2, 4. And then 2.59. And then if I recall, our x-intercept is all the way out here at 14. So 14, 0. So we have our radical equation that looks like that. And we are supposed to reflect about the y-axis. Okay, reflecting about the y-axis. Well, again, if we recall from the original, if we reflect about the y-axis, we only make the x negative. So that's p of x, or p of negative x, that equals negative square root of negative x plus 2 plus 4. There we go. So, interestingly enough, if the x right here is negative, what that does is instead of at negative 2 being my starting point, it's at positive 2, because I need a positive 2 in here for x to make the piece under the radical 0. Or we can just simply look at it on the graph. So here's my reflected equation. Where's my reflected graph? If I reflect this across the y-axis, my y-intercept stays where it's at. However, instead of at negative 2, 4, I'm at positive 2, 4 for my new starting point. And instead of an x-intercept at positive 14, I will end up with an x-intercept at negative 14. So it simply reflects across the y-axis, so everything that was on the left is now on the right, everything that was on the right is now on the left. So there's the radical equation reflected across the y-axis.